everyone, we're going to find the value of x. We're using the angle bisector theorem, and if a point is on a bisector of an angle, then it's equidistant from the two sides of the angle. So basically what it's saying is if this is an angle bisector, that means these two angles are congruent, and you have these perpendicular lines. So this line is perpendicular to this point, and this is perpendicular to this. Then these two sides are congruent, and that's this theorem here, the angle bisector theorem. So we can get started and set these equal to each other and just solve for x. So we have 15x plus 9 equals 12x plus 27. And we're going to subtract 12x from both sides of the equation and subtract 9 from both sides. So this is going to give you 3x equals, so that would be 17, 18. And these two canceled, so x equals 6. All right, and you can plug it in, and if you plug the x in here, then these will be the equal amounts. Now for the second one, we're using the converse of the angle bisector theorem. So basically they're already given that these two sides are equal, and we still have our perpendicular line, and so that means this is an angle bisector, so that means these two angles are congruent. So we're going to set them equal to each other. So we have 8x minus 63 equals, and we're just solving for x, so we don't have to worry about the degrees on this one, it's 27. So subtract 4x from both sides and add 63 to both sides. So you get 63 minus 27. All right, so this is going to cancel. We get 4x equals 36. So divide both sides by 4 and you get x equals 9. And finally we have the last one. So it's the same as this one. These two angles are congruent. We have these perpendicular lines. So that means these two sides are congruent. So set them equal to each other. And we're going to subtract 2x from both sides and add 12 to both sides. So these two will cancel out, 0 out. So you get 6x equals 45. So divide both sides by 6, and x equals 9. And that's it. Thank you. Have a nice day. Bye-bye.